Hello everyone, it is January 21st and today I'm going to be working on LeetCode problem 1344, angle between hands of a clock. Given two numbers, hour and minutes, return the smallest angle in degrees formed between the hour and the minute hand. Answers within 10 to the negative fifth power of the actual value will be accepted as correct. In example 1, we're given the hour being 12 and the minutes being 30. And the output is 165. So that will be because there's a distance of 165 degrees between the shorthand the hour hand and the minute hand. And there's also a distance of, 360 minus 165 is 195. There's 195 degrees as well between the hour hand and the minute hand if we're going in the other direction. So the minimum between those two angles is 165. In example 2, we see it's 330 and the distance between the hour hand and the minute hand is 75 degrees. And then lastly we have 7.5 degrees between the shorthand and the longhand. And it's important to note that they are returning a floating point value instead of an integer. So I'm going to have to take that into account. One thing based off of based off of people's knowledge of how clocks work and the diagram, the hour hand moves at a certain rate based off of the minute hand. It's not always going to stay just at 12 or just at 1. So I need to determine how exactly that rate is created. So let me make some notes, and I'm going to get a sip of soda for 1 second. So if the minutes move, let me rephrase that. So for every hour there is 60 minutes. So the hour hand will move 1/60th of a degree to the right, clockwise, for every minute that goes by on the minute hand. Is that a correct way to say that? So if we're at 30 minutes, then we can multiply the degree, I shouldn't say the degree, but the amount of space for 1 hour, 1/60th of an hour, that gets multiplied per minute. The shorthand moves per minute of the minute hand. So if the minute hand has moved 30 minutes, then we can write 1/60 times 30 equals to 30 out of 60, which means it's moved halfway in between the 12 and the 1 hour point. That equals to 1/2. And then how else can I formulate that? Since there are 12 hours, could I write 1/2 I guess I'm trying to see, I'm trying to find the angle of the hour hand, and then based off of that, based off of the degree of that, I can either take the distance between the hour hand and the minute hand in this direction or that direction, but I first need to find that degree of the hour hand. Because to get the minute hand, I could say there are 60 minutes and 30 minutes is half of that, and the entire circle has 360 degrees, so half of that would be 180 degrees. So I could say that 30 minutes equals to 180 degrees. But at what degree is this? So if that's 1/2 of an hour and there are 360 degrees, (1/2) times 1/12, because there are 12 hours, equals to 1/24. Because, yeah, so that makes sense, because there are 24 halves. And then what is 1 out of 24? So 1/24 of 360 degrees, is that right? Times 360 is, let's see, I don't want to use a calculator, times 24. 24 goes into 36 once. You have 12 left over, so 120 divided by 24 is 5. So that's 15 degrees. So short hour hand equals 15 degrees. Minute hand equals to, since it's 30 minutes, and that is 1/2 of the hour, that'll be 180 degrees. But I also need a formula for finding that. So 30 times, is that 160 equals to 30 out of 60? So then I could take the amount of, or the total degrees, (360 degrees) divided by the amount of minutes times 1 divided by 60 would be 360 divided by 1/2. So that'd be 180 degrees. So I suppose this is the formula for the minutes. And then this is the formula for hours. 1 divided by 60. Hour 12, and then I have to factor in the minutes. So 1 divided by 60 times the amount of minutes is 1/2. And then 1/2 times 1 divided by the hour times the degrees. I'm sure that can be, I'll put M for minutes right here. M. Hour. Total degrees is right here. And then 360 times, or divided by 24 equals to, what was that? What did I say that was? I did it in my head, but I didn't write it down. 1 to 40, so that's 125, that's 15 degrees. I put it right here. What am I saying? Okay. So based off of that, 180 minus 15 degrees equals to 165, which shows up here. But that's one possible answer. I mean, it is the answer, but we need the answer as well on the other side to then do the comparison, to find the smaller of the angles. So 150 minus 15. My intuition is telling me 180 plus 15. 360 minus 180 plus 15 equals to 180, 195. 180, 195. Oh, this is 165 actually. 350, and because 195 plus 165 equals to 360, that works out perfectly. So then we return the minimum between 165 and 195. Yeah, that makes sense. 195 in this direction, 165 in this direction. Okay. And what I'll do first is, well, I want to go through a couple of these examples first, but then when I write the code, I'll implement this formula that I thought of, and then I could try to refactor it. If this works, I'll try to refactor it to make more, I guess, concrete. And then I do need to worry about getting a floating point value if I have to. So why don't I take this formula and this was for example 1. Let's think of example 3. Example 3, hour 3. So let's just copy this over. The minutes was 15, and that is 1/4. The hour is 1/2 times 1/3, which equals to 1/6 times 360 degrees. 360 divided by 6 equals to 60 degrees. And then the minutes formula, 360 times 15. 15 divided by 60 is 1/4. 360 divided by 1/4 is that right? 60 is 1/2. I wrote this wrong actually. It's not, it's times. It's not divided by. Because, yeah, 30 times 1, 30. 30 divided by 60, 1/2. 1/2 times 360 is 180. So it's times. So that'd be 1/4 times 360, which is 90. 90 degrees. So we got 60 degrees and 90 degrees. So for the hour hand, I did 180 minus 60 equals to 120, and then 360 minus, wait a second, let's not jump ahead of ourselves. This is the hour degree, this is the minutes degree. Hour hand equals 60 degrees, minute hand equals to 90 degrees. And then we did 180 minus 15. Okay, the distance between those two is 30 degrees. They're returning 7.5 degrees. So somewhere we messed up. The hour hand is 60 degrees, but if we look at this, it's past the 90 degree mark, which would be at the 3. So maybe we messed up on the hour hand. the hour hand, these were the minutes. That equals to 1/4, which is 90 degrees. So that's accurate. Well, I got it from here though. And then the hours. Why did I put 1/3? It's not 1/3. Yeah, I just inputted the hour I saw, but it's not 1/3. 1/3 is like right here. So I need to rewrite this line. Minutes times 1/12. Half was from the minutes, so I shouldn't have done 1/2. I should have done 1/4. But even still, the 1/3, that doesn't look convincing to me. Maybe it is. What would that be? 360 times 360 divided by 12 equals to 30 degrees. There's something about me doing 1/3. That doesn't make sense. It's not 1/3 because the hour 3 would be 1/4. So then how can I fix that? Let me adjust my posture. Maybe it's the posture that is making me not think as clearly. The hour 3. So 12 divided by 3 is 1/4. And so that's a good starting point. 1/4 of the 360 degrees is 90 degrees, and then we have to adjust for where the minutes are. And then this was 1/12 of the entire 360 degrees, which is I still don't think that's right though. Which would be 30 degrees. No, that's not even right. There are 12 hours. If we divide by whatever hour we're on the third hour, 3 divided by 12 equals to 1/4 times the degrees. 360 equals to 360 divided by 4 equals to 90 degrees. And that's the degree of, without the minutes adjusting the hour hand. So if we say there's 12 total hours and we're on hour 12, 12 divided by 12 equals to 1/1 times 360 equals 360 degrees. And then we once again adjust for the minutes. So take the number of hours divided by which hour we're on times the total amount of degrees. Num hours divided by hour times degrees equals degrees without minutes, without minute hand. So that's a better starting point, at least. And then minute hand was the total amount of degrees times the minutes times 1 divided by 60, 1/2, 180 degrees. I think that's a solid formula. I know this is kind of a lot of notes, but I think it'll be fine. Okay, so minutes times minutes per hour, or no. Minutes times how could I say that? Minutes times, the conversion of a minute to an hour is 1 divided by 60, and then times total degrees equals the degrees of the minute hand. and we get that here. And then finally we need to modify the shorthand, the degree of the shorthand based off of the minute hand. Is that just the total amount of degrees divided by the amount of degrees of the minute hand? 360 divided by 180 is 2. So we would move the degree of the hour hand. No, I'm sorry. 360 divided by, it should be 180 divided by 360 is 1/2. So we just move the hour hand 1/2 of a whole hour, which would be 60. So modified degrees of hour hand equals to degrees of minute hand divided by total degrees. So 180 divided by 360 is 1/2. And then 1/2 times the degrees of 1 whole hour times degrees of 1 whole hour, which equals to 360 divided by 12. Which is 30. Degrees a minute hand. So 180 divided by 360 is 1/2. Times 30 equals to 15. So 15 gets added to the degrees of the hour hand. Of hour hand to get the modified hour hand. Which would be 12 divided by 12, or 360 divided by 360 is 1. 1 plus 15. 15 degrees. And then that works here too. Okay. Are we sure it works here too? Because we didn't test it. At this point, I don't feel like, I would never say this to an interviewer, but I don't feel like going through a test, but it's just necessary, because I mean, I am 34 minutes into a solution, which is already pretty long. This was a lot of notes, but if I start coding it and then it doesn't work in example 3, then I'm really well, I'm doing not well. Okay. So that was 90 degrees, 360 degrees, And then the minutes times 160 divided by the degrees. The minutes is 90 times 160 is 3/2. Which is 1.5. The degrees of the whole hour is 30. Oh boy. Degrees. 90 degrees is of the minute hand. The degrees of the minute hand divided by the total degrees (360) times the degrees of one whole hour. (90 divided by 360 is 1/4. 1/4 of 30, 1/4 times 30, 30/4 is 7.5. Equals 90 times 30 equals to 7.5. So then, because it was hour 3, we add 7.5 to the degree of the hour, which would be hour 3, which would be, hour 3 is at 90 degrees plus the 7.5 degrees brings it to 97.5 degrees, and then we have the minute degrees. So 97.5 minus 90 is 7.5, and that's how we get the output. Okay, I'm going to start coding this because I've reached a point where perhaps my explanation, my exact formula isn't exact, but sometimes I think I just got to get going now. Okay, so to get the hour degrees without the minute hand equals to 3 divided by, or the total amount of hours is 12 divided by 3, 12 divided by hour rather, times the total amount of degrees, which is 360. Minute degree equals to minutes times 1 divided by 60 times the total amount of degrees is 360. Modified degrees and I can rename these. The modified degrees equals the degrees of the minute hand, minute degree divided by the total degrees times the degrees of 1 whole hour, which is, why did I put 30? The minutes degree divided by 360 90 divided by 360 times 30. 1/4 times 30 . Fifteen divided by 60 is 1/4. The minutes degree is 90. And then 90 divided by 360 is 1/4. So 1/4 of a whole hour would be 15. So it's of a whole hour. Would be 15. Okay, so that's 15 degrees. But I don't know why I put 7.5. Well, I mean, I know why, because I put 30. So that'd be 15. I probably saw the 7.5 here and just made a mistake. Like I wanted it to be 30. Okay, so that's 15 degrees. So then the hour degrees plus the modified degrees is the new modified. So that would be 90 plus the 15, which is 105. But that's not right. 12 divided by an hour would be 4. I don't know what I'm thinking. 12 divided by an hour would be 4. So it should be an hour divided by 12. Hour divided by 12 would be 1/4. 1/4 times 360 is 90. Minutes degree 15 times 1/60. 15 divided by 60 is 1/4. 1/4 times 360. 90 once again. 90 divided by 360, 1/4. 1/4 times 60 is 15. 15 plus 15. 90. 15 plus the hours would give me 115. But we get 7.5. So, I mean, I could just divide by 2 and that would give me what I need. That'd give me the answer, but that's not exactly the correct approach if I can't name why I can divide by the 2. Let's just see what happens. Hour degrees plus modified degrees minus the minutes degree divided by 2. So that'll work for that. Return the min between that and what else? Between 115 and what would it be, negative 90? No. 115 right here. negative 90 degrees to get there. So minute degree, and now this space is covered, and now you need the space to get back here. So it'd be plus the modified degrees. No, not plus the modified degrees, because that's the space from here to here. So it'd be 360 minus modified degrees. So if modified degrees is, no, it's hour degrees plus the modified degrees. Oh boy. $360 minus the hour degrees, which would be 105, which would be 360 minus 105 is 255 plus the 90, which would be 345. Yes, so that is the space on the outside, since the space inside, no, it wouldn't be 345. If the space is inside is 7.5, then the space outside has to be 352.5. Man. The hour degrees plus the modified degrees is 105 minus the minute degree. I mean, yeah, this isn't good, me dividing by 2, but I'm just getting so hung up on the solution that too much rigmarole here. It was too confusing of me going back and forth. So I should have tightened up these notes and came up with something more concrete. Probably not written these full sentences, because after a while to my eyes it starts to get just, it gets to be too much. The hours degree, okay, 90 plus 115 is 105 minus the minute degree, so that's 15 divided by 2, for some reason divided by 2, 7.5, and then 90 plus 360 minus 90 is 270 plus 285, and that is 285. That's not right. should just take this and then take the opposite of that by saying 360 minus whatever that is. Now I'm getting desperate. I can't even get the parentheses right. Okay. Okay, that's irrelevant. I don't even need those. Hour degrees plus 1 minute degrees minus the minute degree divided by 2. Okay. And then 360 plus the hours degrees minus the minute degree divided by 2. $90 plus $90 plus 15, 115, or excuse me, 105 minus 90 is 15 divided by 2. Right. I'm not satisfied. I don't want to look up what to do yet because I'm feeling a bit stubborn. Okay. Hour divided by 12. The hour is 12 divided by 12, 1 times 360 is, for example, 1 is 360. It could be 360, or it could be just 1, right? Minutes plus 1 divided by 60. Minutes are 30. 30 divided by 60 is 1/2. 1/2 times 360, 180. Modified degrees is 180 divided by 360 is 1/2. One half times 60 is 30. But that doesn't mean it moves 30 degrees. It moves 30. That means it moves 1/2 of 1 hour. If 1 hour is . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . if 1 hour is, what is it? 360 divided by 12 is 30 degrees, then it moves 1/2 of, but that's just a coincidence that it was 30, right? Thirty, 1/2 times 60. It moved 30, so that's 30 modified degrees. 30 divided by 360. No. Minutes degrees. 180 divided by 360 is 1/2. 1/2 of 60 is 30. Should I have done 1/2 times 60? Or 1/2 times the amount of degrees of 1 hour, which would be 30. So that'd be 15. That sounds better. 1/2 times 30. It's 15. Wait a second. But why did I put 30? What was 30 from? Oh gosh, I'm getting myself all over the place. The minute degree is 30 divided by 160. 360 is 1/2. 1/2 times the amount of degrees in 1 hour. So that's fine. 30 equals amount of degrees in 1 hour. I'm just going to erase that. Divided by 12, 1 times 360. One divided by 12, or 12 divided by 12 is 1. Maybe I shouldn't have even said that. If the hour is 12, $360 minutes times 1 divided by 60. 1/2, 180. That looks good. I'm starting to think there is an issue with how I'm setting the hours degree. Minutes degree is fine for now. should I just say 1? If hour was 11, what would that be? Okay, let's say the hour is 6, then that would be 1/2. Then I could say 1/2 times 360. And that would be 180. But me saying 12 would be 1 and then 360. Modified degrees equals to 180 divided by 360 is 1/2. 1/2 times the degrees of 1 hour is 15. So 15 degrees past where the hour degree is would be 375. Hmm. Fifteen minus minutes degree, the absolute value of those. 15 minus 90 . No, 15 that'd be negative 165, then 165 versus the opposite way, which would be 360 minus the absolute value of that. So if this is 165, the absolute value of that would be 360 minus 165 would be 1. Yeah, 1. Or it'd be, yeah, that would still work, 195. If this worked for all of them, I'd be very happy. If it doesn't, I would understand, because I was all over the place, but all we can do is hope for the best. Well then, I am happy. I'm a happy sailor. This took a record of about an hour and 5 minutes, hour and 10 minutes. And my notes were all over the place, and I wasn't great at explaining the concrete formula of how I was going to implement it. I understand that. I did a good job debugging, I think, and I was pretty persistent in figuring out where I went wrong. But I got the problem nonetheless, so I'm a bit happy that I didn't give up. And yeah, I am happy about that. So with all that in mind, let's input our solution, and I'm gonna also input my notes into ChatGPT just to see if they could reformulate my notes and structure it better, or give me tips on how I could have structured it better. Notes mix units and partial derivations. Yes, that is very, very true. The modified degrees, okay. Hour hand moves 30 degrees per hour. Yeah, I was a bit hesitant to use the modulo operator at first, but that did help. Ooh, okay. Yeah, these notes are very, very helpful, and I think in the future, when it comes to my notes and coming up with the rules of the problem that I have to, not the rules, but the patterns that the problem abides by, this is helpful, writing something like this. Our hand also moves 0.5 minutes, 0.5 degrees per minute. Minutes times 6. Yeah, converting back and forth between degrees and proportions is definitely what I was doing, and I was getting hung up because sometimes I was confusing whether or not certain numbers were degrees or minutes that I was previously referring to. Excellent point. Interviewers love when you define constants up front. This right here, help you practice writing cleaner scratch notes scratch notes under time pressure is something that I really need to implement, because I think that I was all over the place for this problem, but in general, I like to write my notes, but sometimes even for brute force solutions, I'll walk through the entire brute force solution in my notes, and I probably waste a few minutes that I shouldn't, that I should just talk through the brute force solution in such a simplified way that notes aren't even required. So I'm definitely going to work on this, and then as well as making sure that I'm not switching between different units. Okay, everybody, well, that is all for today. Thank you all for joining me. I know that was a bit much. I'm certainly happy that I didn't give up too early, though obviously I'm not going to be given this much time during the interview, so I do need to work on a couple of more things, as always. But I hope you enjoyed watching this, and if you want to work through the problem yourself, it's an excellent problem. Okay, that's all for tonight. Take care.